next presentation, we have Trimble new products. And here we're going to hear from a couple guys with Trimble, Pete Mestemaker and Skylar Newmeyer. Hopefully I'm pronouncing that okay, Skylar, if you can hear me. Just a quick intro to Pete. Pete's worked as a surveyor for 9 years in Colorado before joining Trimble in 2005. His roles at Trimble have included training, working with the marketing assistance and testing team for geospatial, and now sales for the Western U.S. distribution partners. He is married with 2 kids and lives in the Denver area.
Now I'm going to pass it over to Skylar, let him talk about the MX9. Did we have any questions, Troy, on our 780?
We have a couple questions. I don't know if you have a feel for this, whether the X12 requires periodic calibrations, or if there's some internal calibration and checking that's going on there.
Well, so the X12 is not like the X7, right? So the X7, as long as it does its auto calibration prior to every scan and it passes, okay, the X7 does not need to go in for service. The X12 will need to go in for service. Now, what I don't know, Troy, is if that's an annual service or if that's every 2-year service.
Gotcha. And then one more question. Actually, this is a speculative question about just, this is a total speculation on your part, but we want to ask the questions as they come in about tip technology as far as survey rods, sending the rod heights and other, orientation information to the controller, like rod alignment, tilt. Did you catch that question, Pete?
So I heard you cut out there just at the very end, so I didn't really get a question out of it, though.
Well, just your speculation from Trimble as far as putting some of these tilt sensors and so forth in a rod.
Oh, in a rod as opposed to in the receiver head.
Check.
So yeah, that's not anything really that I could touch on right here, Troy. Me being in the sales side of things, right? They intentionally keep anything that they're working on from a new technology standpoint kind of out of our heads, so that and with Trimble being a publicly traded company, it's against SEC rules for us to talk about anything that's new or upcoming that is currently unreleased. But again, they typically keep that type of information kind of tight-lipped and out of the sales organization, so that we don't have a slip of the tongue and say what's coming up. So no, I can't really speculate on that.
Totally understandable, Pete. We can go ahead and move on with Skylar.
Okay, great. Thanks, everybody.
Alrighty, I'll give a short intro. My name is Skylar Newmeyer. I'm a little bit newer than Pete. I've only been around Trimble for about 5 years, but used Trimble equipment for 5 or 10 years before that. Was previously an oil and gas surveyor on like the North Slope of Alaska, doing mostly stakeout for seismic work. Then I started at Trimble in the market acceptance testing group. Specifically, I worked on the R12I's tilt compensation calibration routine and a couple things in the X7. And that was around the time of the initial release of the MX9. So I started testing that, and then I've been working in various roles related to the MX9 since then. Today, I test new mobile mapping systems while they're under development. I do some, demos and talks like this, and then I also focus on the feature extraction side of TBC. So we'll talk about that a little bit at the end. So what is mobile mapping? It's going to be kind of any collection that is, a vehicle-based system. Generally, it's going to be a LiDAR and camera sensor integration. We have a whole range of those with kind of various combos, but some of the typical ones you'd see are, the camera systems. A lot of people, I kind of describe it to as Google Street View, but for surveyors, you have the imagery, but you also get the point cloud that goes with that. And that's my kind of boring dictionary definition, but yeah, it's any geospatial data collected from moving vehicles. So some people could say, a rover attached to a side-by-side could technically still be mobile mapping, but we're more talking about the kind of more expensive integrated systems. So what does it mean for an actual surveyor or GIS tech in the field? So I think it kind of ties in good to the initial presentation during this about, manpower being one of the hardest things to find these days. It's really just I think the term used was a force multiplier. So it just allows, a 1 or 2 man crew to do the work of 10 survey crews. So that's really where we see the biggest advantage of mobile mapping is speeding up large scale collection just, tenfold. So we'll talk a little bit about why Trimble and our portfolio. So we've got, 15 plus years of experience. We actually purchased a company that had even longer experience than that kind of turned into our mobile mapping division at Trimble, a company called Geo3D. Nowadays, we're kind of coming to a culmination of a lot of that experience. If anybody in the room has experience with older mobile mapping systems, they're very different than they were 10 years ago. 10 years ago, we would receive a vehicle and spend months integrating a system into the vehicle, and the company would come in for weeks of training on how to run it. Nowadays, I can get somebody up and running in about 30 minutes on the field collection side, and then we usually do, a 4 or so hour kind of up to speed on the office side. So the usability, the portability, the systems have come a long way since we started. The MX9 here on the left is our kind of entry-level system. So it's image only. So you'd kind of get a result that's similar to Google Street View, like I said, but the images are correctly georeferenced and accurate. So we can extract things from those images at about that kind of 10 centimeter accuracy is kind of our best goal with the MX9. But it still has a lot of dedicated users in the GIS space. So, extracting things like trees and signs and poles, things like that. Images are sufficient for a lot of those uses. The MX50 is our kind of mid-range one. It's our newest system. That's what I presented on during this conference last year. It's been a real hit. It's a great value. So we've kind of found that it's actually our biggest seller out of the portfolio. I think unit-wise, it's something like the other two combined. It comes in a couple different configurations. So it has an AP20 IMU, which is kind of a more GIS grade, mapping grade IMU. Or you can also now get it with the AP60, which is the full high-end survey grade IMU. I think, if my dates are correct, last time when I presented this, the AP60 option wasn't available. We did get a lot of feedback that people wanted, the kind of mid-range, a little more accessible system, but still that high accuracy. So it's going to have a little lower density in the scans, but they still wanted to be able to get that survey grade accuracy. So now we offer that combo. And then what we'll be focusing on today, the MX9, is kind of our top of the line premium system. Thrown back to Pete's presentation, it would be the R12i in this lineup. It's basically going to compete with the highest end systems in the world. So it has the highest end IMU that's pretty much commercially available. It has the highest density and longest range lasers. It's just kind of does everything, but at a cost. So some key points on the MX9. I did want to highlight the colorization. It's not quite as good as Pete's X12 colorization, just because we're moving at 65 miles per hour. But we've done a lot of work recently to improve the colorization on all the mobile mapping systems. Colorization used to be just kind of a nice to have, a little bit of a marketing thing, but I wouldn't really use it for actual work. But after some of the improvements we've made, I can actually extract, all this line work based on the colorized point cloud and come in with, around 5 mils from if I was doing it from an intensity-based extraction. So the accuracy of the placement of that colorization is really, reaching a point where we can use it. On the top right here, you'll see the interface that can be ran on a T100 or an iPad. You can bring your own device. You basically connect to a Wi-Fi point that the MX9 generates, and then you run it here. Like I said, this has come a long way. You used to have an actual computer with monitors and a keyboard set up in there. You were running multiple softwares at the same time to get the systems to run, 10 years ago. Now I can run it on my phone if I want. And basically, during early testing of the system, we just handed this to somebody who'd never been in never ran a system before, gave them 10 minutes, and they were able to start recording and kind of working their way through things. So we spent a lot of time trying to make it much more approachable than it used to be. So you can see in the bottom right of the UI, there's a record button that then turns to a stop button. You have background maps to kind of see where you've collected, see where you're supposed to still collect. You can upload KMLs of your routes and basically just follow those along. I think one of the engineers early on, we kind of were talking about it, and they wanted it to, one of their goals is they wanted to be able to just hire a taxi driver and throw the system on top and send them down the road and be able to start recording. And I think we're getting pretty close to that being actually usable by just anybody. The last key point on the MX9 is that high density. So that's really the main differentiator between the MX9 and a mid-range system or a lot of competitor systems. So the updated MX9 can achieve 3.6 million points per second at highway speeds, which honestly, at this point, there's not really any need for any more density than that. There's only some niche use cases where I run it at the full max density. Some things like road condition reporting and things like that, you do want high density at, 70 miles an hour. But we're kind of reaching a point where there's not much need to add any more density. All the extraction tools that I work on work just fine with it turned down a little bit. So let's actually look at the software a little bit. I'll start this video. There's no sound or anything. I'll just kind of talk over this video. So TBC is going to be your main software for processing this kind of data. So nowadays, the trajectory correction, the cleaning up, the colorization, all of the mobile mapping processes are in the mobile mapping module of Trimble Business Center. There used to be, I keep kind of throwing back to 5 years ago, but I think it's just a good contrast with how much better things are now. I used to have 3 or 4 different software packages for different steps. Now I'll be start to finish just in TBC. So what I'm highlighting here is the curb and gutter extraction, which actually works great with mobile mapping data because one benefit is you have a very consistent density compared to static scans where you might have high then low density. So a lot of these extraction tools work great with mobile mapping data because they just have a nice consistent point cloud to work with. You can see this data here is, I think, an MX9 that was actually turned down quite a bit. So we could have, close to twice this density at, 45 miles per hour, which was the speed on this project. But again, at those densities, it's a lot of extra points that we don't really need to define the shape of a curb or to find the road marks in the point cloud. I'll let this video play out for a few more seconds. And then I just want to highlight one thing where like that little curb section wouldn't be too hard if I had, a rover and I went out and just staked it out. But once you start doing that for 100 miles or 150 miles, or I have projects on my big desktop at home that are, terabytes and terabytes of data. I think I have over 50 terabytes of mobile scans. Those little examples that sometimes we show in these presentations, you might think, oh yeah, I can go survey that in a similar amount of time. But once you get into these, 15,000 mile long, multi-year projects, that's where we really start to see the kind of need to use this data. There's a lot of smaller projects that could benefit from using a mobile system, but at a certain point, it just kind of becomes impractical to do it any other way. So we have customers all over the US that are doing, 14,000 mile projects. I had a 27,000 mile project that concludes sometime this spring. Kind of have to start using this data at some point. I wanted to touch on some of the other software packages. Like I said, you can stay in TBC for the whole process now, but another software that we sell is TMX. It's just a feature extraction software that kind of handles things a little differently, has a few more features than TBC because it is kind of focused on just the extraction process. So you'll see here, I'm automatically extracting trees, which is something you can do in TBC. But it's a little bit of a personal preference thing. We have some customers that like to use TMX for some of these uses. We have some customers that like to use TBC. I just like to highlight, both techniques. They kind of work in a bit more of an image-oriented workflow, so they kind of focus their workflow on using the 360 image to kind of navigate through your project and go through and extract everything. And then I'll go to the next one. This next step down here, I'm just doing some automatic power pole extraction. So you can see I'm basically giving it a boundary to search through and then giving it basically a seed pole that gives an example of what I'd like to find. And then once I've done that, I let it go through and search for other ones that are similar to the initial pole that I gave it. Then you can go through and QC it, and it's all stuff that you guys are probably familiar with from working with static scanners. A lot of the same techniques apply to mobile scans. It's just a different collection method. Got a few more seconds of this video, and I'm just kind of QCing it right there. And then the last one I wanted to show is a software called Topodot. We work with them a lot. We have quite a few of our users that use Topodot for some of their extraction, and it's a bit more survey focused, where TMX, I would say, is the more GIS focused kind of software. If you're familiar with this UI, Topodot is a module that runs on top of MicroStation. So MicroStation is required to run it, but it can be a basic kind of cheap MicroStation license and let Topodot do most of the work. I'm just doing a quick lane line extraction here, which is one of my favorite tools in Topodot. Their lane line extraction is quite good. And you'll see here in 1 second after I finish this last line, I'll kind of zoom out and show how much lane lines I extracted just then.
Wow.
I'm going to do these interior lines. And I do really like our lane line extraction because I kind of worked on it, so I'm a little biased, but theirs is actually a little faster. We kind of focus a little bit more on staying perfectly centered in the line and a few other things like that, but I will give them credit where credit's due. Theirs is very, very fast. And as I start cruising here, you can see that was, I think it was about 2.5 miles to this intersection. And then you'll see the one lane that continues goes, I think, almost 4 miles as a total extraction for that. And one thing I like about the lane line stuff is it keeps me from playing Frogger in the road and having to actually, boots off the asphalt is a big use case for a lot of our users. A lot of our DOT users, that's kind of, they don't really care as much about the time savings or things like that. Their main reason for utilizing this technology is just keeping their guys off the highway, avoiding road closures, things like that. All this data was collected with the roads fully open, didn't have to slow down or anything like that. That was the last video I had on the extraction side. If there's any questions on mobile mapping, I'd be happy to cover them. Otherwise, you can find my contact info or reach out through Monson and we can talk about anything else. Any questions?
Really quick, Skylar, we did have a question. How will ArcGIS Pro handle point clouds from the MX9?
Great question. So it doesn't handle them very well because we have so many points. ArcGIS Pro doesn't love the huge point clouds. I've actually talked with some of our colleagues over at Esri about it, but I do have a good workaround. So if you drop a 10 billion point cloud into ArcGIS Pro, it's probably going to lock up. It's not going to have a fun time. TMX, so this software that I was showing, actually has a plugin for ArcGIS Pro. So what you can do is basically have TMX handling the point cloud and processing it, but then there's a window that would open in ArcGIS Pro. Any extraction, you then hit sync and it just instantly shows up in your project, and it does go both directions. So you can, take any of your GIS data from your ArcGIS Pro project, sync it one direction over onto your point cloud, click extract, use your tools, click sync, goes right back over. Another integration will also be the TBC Esri geodatabase integration, where you could work with the data there, sync it to an Esri geodatabase that then you would open in your project. But long story short, you don't want to bring the point cloud actually into ArcGIS Pro, or at least a big one. Something like this one, maybe half that project would actually function in ArcGIS Pro, but when you get to the big 100-mile projects, there's no chance.
Okay. In the interest of time, we'll probably need to proceed here, but there are a couple of other questions that I'll make sure that we get to. I get to you and Pete. But is there anything else that you guys had to share, Pete or Skylar?
I think we're good on our side. Thanks for everybody's time, and like you said, get us those questions, and we'll reach back out to people.